I'm determined to get this lock done. We've done that bit, haven't we? Yeah. And it's going to be, the thing is, thinking a thing is one thing. Writing a thing on paper and planning a thing is completely different to making it and then making it work. So we've got quite a thought-provoking mechanism. I've thought of the idea, now we've got to make it. Well, this was the initial, Scoutcrafter sent me this originally, didn't he? And we've made that bit fine. And as he said, it was a genius idea of welding the bolt onto the plate and then cutting the plate from behind. Well, I robbed that from Steve from On Tools. I robbed the idea from there, to be honest. And we've got to make, and how are we going to get these to get together closely? On a door, the door is already married up and you just put these in place. But are we going to get these to slide inside a groove of some sort? Are we going to completely change that and just get some sort of a connection there? We're going to attempt to put that here somewhere. We've got to get through the hole. We're going to make it like this now. Let me just explain. You've all seen this. But the technical features in this is, you know, we've put a big bolt down there, put a cut in it, that's a thread, so that turns it like almost a screwdriver. That's the key to it, you know what I mean? But this going down is fine. And we come through the door, so that movement over there needs to be turned into a movement up over here, which is fine. So we follow. Now if it was just straight up, it would be easy, because it would just go straight into the roof here, which would lock the door. But the problem I'd had here was, how do you transfer a shaft going up, that movement, into a shaft going along? So we did this, didn't we? So how do you make a up movement into a cross movement? And of course, we had to replicate at this end for this to go in here. So then how do you transfer a movement going across back into a movement going up to give us two locks? So, so it had to go down, which meant up which meant along, and along, which meant up again. So, right. So now, this one, we're going to try and make an in and out movement into an out and in. So this is quite simple. You move this bar to the left and the pin moves out to the left. You move this bar to the right and the pin moves to the right. But we're going to try and make it in means out and out means in. Left means right, right means left. So how are we going to do that? I guess we've got to make a few prototypes. And if we had a Meccano set, it might be easy. If we had a flat board. And what's not going to make it even easier is we're making it on the hook. We're making it on this door here. So it's not a case of mock one up is the word, or, you know, put it in a CNC on a drawing measurement. It's going to fit where it touches, and what works will work. Yeah, so as usual, less talking, more doing. So let's begin in the beginning, shall we? So we've decided we're going to use this. So in means out at the top, in means out at the bottom, and out at the bottom means in at the top. So we've decided we're going to use this, aren't we? So let's weld this up together first. So whenever you're doing something small and fiddly like this, It's so easy to just forget and grab it. That's taking your skin off heat, that is. So always wear your gloves, and in between every move you make, you quench it and you make it cold, because it's so easy to just grab it. You know, you're doing something and you grab the wrong end and you've burnt the end of your fingers. So everything you do, quench it, make it safe to move, or safe to handle the other end of it. But you tend to weld one end, turn it round, weld this on, and then grab it by the end that you haven't cooled, and you've got yourself a nasty burn. Believe me, I've done that experience. So anyway, we've done that bit. So I imagine this sitting here doing that, throwing the levers in and out. So I think we're going to be all right there. We've got an existing hole that we've done for whatever reason. And this is a bit small, isn't it? So we like that, but we could do with a bigger bolt. Could we? Shall we bother with a bigger bolt? And it's got to be offset slightly, hasn't it, to make it work. It doesn't rub anything. It's got to sit up off the surface, hasn't it? It's got to sit here somewhere. So we can at least get behind it to do the link. So, let's figure out. Are we happy with placing it there on the door? Throw it in, throw it out, throw it in, throw it out. Yeah, not too much of a movement neither. So I think, yeah, we'll use this existing hole. We'll put a longer bolt in and we'll come off the back of here. That'll support it and it'll be solid. Okay, let's do that then. So I've just discovered why it goes so far and goes tight, and I've discovered why these were knocking around. Is we must have used, you know, you've seen lock nuts, haven't you? Well, these are one of them crushed thread nut things. So it does the same job, it jams itself on, which it doesn't really matter much, because we're only going to get that sort of movement out of it, but we're going to lose the adjustability in and out, how far we want to offset it. Shall we stick with what we've got, because we only want that sort of movement out of it, which works fine. We're going to lose this adjustability in and out. Is it worth the effort? It's one of them, you know, designed to be crushed nuts and go on tight. You can see it, can't you? Can you see it? Look. An alternative to a lock nut, but it's a lock nut. Anyway, we'll crack on. It's going to be just fine. We're going to have to redo this because I want that adjustability to be able to go in and out a bit. So do we remake this, or do we just drill a hole there? I think what we might do is we'll just drill a hole there and simply weld another new one here. Yeah, that's better. That's going to give me a lot more although it's only going to do this, I can adjust it in and out as much as, or as little as I want. So that's the one. I've sort of crushed that into place. I drilled a hole. I drilled the other one. I drilled the other one out. So I'll go through there and easy, and just crush this to make it so it'll sit level. So let's see if we can weld it without getting a spark in the damn thread and completely sending us back to square one, so that we don't get a spark inside the threads. We'll put this in there, we'll block that hole up almost, as you might say. Piece of wood could have done it, I suppose. And then we'll come from here and weld into there, see how we get on. You do a good job. I'm trying to clean them, make it clean and then weld it. Yeah, instead of usually you weld it you bang it, it breaks apart. You've got to weld it again. So I am trying to do a proper job and clean things up. So those little rods didn't really want to work on this, and look, we've caught the top of the thread, but don't worry, it's not jammed it completely, just about caught. We've got to get out with this now. We've got to get out. You can see where it's just catching there, look, still. So we'll just grind down until that disappears. You see, look, without a bother. Leaving that in there turned out to be a wise thing. Yeah, just it sort of protected the hole in the thread, didn't it? Yeah. So we can move on now, can't we? Move on to the next bit. We drilled a hole in the nut that was not right, and we welded in a new one, and we got caught, but we got around it, so that'll do us just fine. Nice and easy working. So now we've got to concentrate on this bit. What are we going to do here? How are we going to make that work? And how are we going to support the shaft? Because of this, it can't be like a welded T, because it would be, hold on, can't weld it solid there, because they would both go in and out together. So we've got to make ourselves some sort of knuckle. So that goes in, this comes out, that goes in, that goes out. Ooh, oh, we're getting there. We've just got to, how are we going to do this? What are we going to do with this here? Because it doesn't matter about the end, because if we make it too long, we can always cut the end off to suit us, can't we? So this has to stay level. Do that, look. So what are we going to do with that? How are we going to do that? And what space have we got behind here to play with? Not much space. It's on the surface, but the trouble is, it would be nice to have it flat on the surface here, it's close to the door, but it would be easier to work it here, but it'd be sticking out from the door, wouldn't it? And the bolt across, although we're using a thin bolt, the bolt across doesn't really matter, because we've got our security. It's just the exercise we're doing, isn't it? So I can't afford these to be crooked or bent in any way, so put that there, put this here, squeeze that up there, weld that little nut on the end so it matches up together. We jam it in here together, and that's going to be pretty much close in it. A little nut here, a little nut there, and that's going to do the trick, I think. So I was hoping that would do the trick, but it's a bit too deep, isn't it? So we can either cut the threads off later, or for now we'll hold on, for now we'll do it this way around. But it don't really matter, because you know, it's not too far, it's not further out than this, is it? So out is in is out. We've got that far, and we're not far from the threshold of the door, are we? No, that's slightly twisted. That one's slightly twisted more. Maybe we can bend that or something, or it won't matter, because we'll just bend the shaft to suit. I thought that was going to come out squarer, but it didn't. Still, we wouldn't be ready-made if it wasn't crooked, and we didn't have to work around it. So I reckon now, shaft and a nut onto a shaft here now, and let it overrun. But don't, let me just hold on. So we've got to put the shaft here. That's going to be fine, right? But we've got to we've got to make sure that when we wind it back on, it doesn't foul itself on the end there. Look, not there. It can go around, so we can thread it on, can't we? Yeah. If you know what I mean. If we did it there, it wouldn't pass that, would it? So we've got to make it there, short enough to pass there. Yeah, which is good. Short enough to pass there, long enough to reach where we want to go in and out of. Or shall we just make it all together? Put a bigger nut on here. See, we could put a bigger nut on and sit it in there, and then put a nut on the end of here, use it like that. See, we could, because we've still got to make some sort of a keep to keep the ends of these in place. So, are we gonna do it that way? On there, which you could. We're gonna do it there, which you could as well. But if we do it there, we'll have more of a chance to make it work, won't we? But you've got to leave a certain amount hanging over, because we're going to try and connect through the door on a shaft going along here somewhere, somehow, or up, or so. No, I think we'll do it there, just on the, yeah, on an individual one, so that reaches in and reaches out. Like I say, the end doesn't matter, because we'll make that fit, and then we've got to make some sort of a plate for these to stop them from dropping down after. So I reckon a nut there, and a nut there. But then you won't be able to wind it on because this is too long. See, we'll get to a point where it won't pass there. So it's got to be, hold on, it's got to be thread onable, as you might say. So if you put it there, you won't get it past there. So it'll have to come at least to there, so that you can wind it on. So when you wind the thread on, it'll pass, won't it? Yeah. So virtually has to be in the middle then. Yeah. And if we have to extend that, we can do anything the hell we want. We can. This is just a plate, so if it means just thinning this plate to get it in, it don't matter. So let's just basically put them in the middle, I think. Yeah. Because otherwise, if you put them on the end, you won't be able to thread them on, because it would foul, wouldn't it? Yeah. So I like these nuts when I'm welding, because it just gives you that little bit of material to stick to. It just gives you the edge. It gives you something to lean up to it if you're on a shaft or something like this. But then if you like that, look, you've got that to fill and to reach across. But when you're just beginning, it just gives you the edge. So now you only have to reach to this here. So we'll start here and we'll just touch that there, and we'll come back again. And that's good enough to hold it. And then it'll be in a good position then to come across and do this. But again, we'll put a nut in there so that we can't jam ourselves. So I do like these nuts when you're welding and inventing and making, because that little bit of an edge just helps that little bit. I nearly fell in the, I like these, but I nearly fell in the same trap that I fell in earlier on the other job. I like them, I use them, but I've just noticed these particular ones, if I can get the thing to thread together, come on, there we are. These particular ones are those crushed end ones again. Lucky, I was just going to put that in to try it. So, are we still going to use them because they're easy to weld? We're going to go and find some more, or they only seem to be crushed at the very end here, look. That end piece, almost as if it's been put onto it. So maybe we might just drill that out a bit on the end so that it goes through. Let's go see what we can find. We're bound to have something similar, but I nearly fell in the same trap that I was earlier because I like these nuts with the shoulder on. We could just weld these on it, these little thin nuts here, because again it's not going to move much, it's only going to do that. And if we do get a problem, we can just drill a hole through these and be a nice slack little strong joint. We could tighten it up with them maybe, or even put them on backwards and use the tightness first. We might just weld them on it, little thin nuts, and if it threads on it's a bonus, but if it doesn't thread on we haven't got much drilling to do. We can just bypass the thread and drill a hole straight through there, can't we? What shall we do? So always the way, you try your best not to hit anything. No, you try your best not to hit anything, you hit it. And when you don't care because you're going to drill it out anyway, but look, that's passing that and that's threaded in. And we've got this one which we hit and we're going to drill it. So we're getting there now, aren't we? In is out, out is in. It's a bit, I quite like this because it's got a little bit of a wonkiness, a little bit of an adjustment, shall we call that. This has got less adjustment because it's properly on there. So I quite like, I think we're going to go down that path. I think we're going to go this way. So let's drill this out. So do you see how it's going to work now? Come out a bit. In is out, out is in. Hold on. Right, so when it's fully open, when it's fully shut, it will be locked, and when it's fully open, it will be locked. It will only work when it's in the middle. And a bit more. This is okay. This, I think I'm going to drill it out and try and bend this way, maybe twist it or something. It's a little bit too far out. Then we've got to make a keep here, haven't we? We've got to put a strip of metal and a nut, and a strip of metal and a nut bigger, so that these got somewhere to slide in and out of. The tube is better because they won't jam then, so we could do with a tube, couldn't we? But that does go up and down. A nut might be the thing. So we're getting there. Yeah, we've got to where I want to be, because fully open is shut and fully shut is shut. Yeah, we're getting there bit by bit. Let's drill this out. Let's see if we need to tweak that or tweak this, and then the next job will be to somehow control it and then flip the whole thing around so that these are closer in to there. See how much space, see how much stuff we can cut off. But that's all tweaking it afterwards. At the moment we're just getting the idea to work. So if it's shut, it's shut. But then when you fully open it, it's still shut. It'll only work when it's in the midpoint. We'll cut them off to fit. We're getting there, we're getting there. Yes. I know it was OTT, but it did snap the weld on one half and it's holding on the other half. So all we have to do is weld it back together. But that's what straightened up the little nut. If we've got it, we may as well use it, mightn't we? I know it's a little bit OTT. See, it just simply tore that out of there now, but at least now they're a bit more level. It's hanging on here just, so let's just weld this in here, see what happens. It's level. It's leveled them out, hasn't it? It's done a good job of leveling them out. Wow. Yeah. So if you've got the biggest tool you've got, and I am the biggest tool you know, why not use it? That's they're pretty level now again, aren't they? Ooh, yeah. Oh, I'm thinking trim this all back, get this piece of angle iron, fit it there, almost tech screw it in if you had to, and then a nut here welded and a nut there welded, and these would go in and out the nuts, wouldn't they? They have to be shafts, don't they? They can't be nuts, they've got to be shafts, and the end will be strong. Bring that in a little bit, bring that in a bit to about there, that's going to help it. I think this is where a box spanner would be the trick. Weld a box spanner on here, run these up the inside of a box spanner, turn them round, run them on the inside, make this a bit longer, cut that a bit shorter. I don't want to risk cutting that shorter now and turning it round. Not yet. Anyway, let's have a look. It had to go this way on, didn't it? Because we welded the new nut there and we drilled out the old one here. But see, there's that much to go, isn't there? So it might be just as easy to weld another nut on here. Yeah, just weld another nut on there, and then that would begin to thread there. That would allow that to go in. And hanging on there would be this, hold on. This would then, turn it the other way around, hold on. This would then be hanging on there. Hold on, right. So this would then be hanging on there at that distance, which is going to be all right. And we won't have to cut too much. And we won't need even to put a nut on the end of it. Maybe that's the way to go. Yeah, let's weld a nut on there and see what happens. So to make sure you don't misalign this in the wrong place, so that when you screw this end in it doesn't marry up with this end, you just put a bolt through here. It's slightly off center of the hole, which is to be expected on a Reggie jobby. It doesn't automatically mean it's going to come straight through the middle of the hole, but as long as it comes through, that's all that matters. So what we'll do here is, we now know that's going to go through there. We'll bolt this up tight onto here, we'll weld this onto here. We know the bolt's going to go through, and again, if we do catch the top of it, we've got to get out, haven't we? Always the way, as you solve one problem, you create another. This is working fine, this will screw in, but then you can't get these in, round and past. But that's no big deal, because we'll just have to withdraw this screw. We'll just have to readjust this one out, won't we? So we'll put that in, pull this up, tighten it on this bolt here, pull this out. If we have to cut the end off that, it doesn't matter. But isn't it funny how fixing one problem creates another problem? But I'm quite happy with it there, because you've got less stuff to bump your legs into. So the next move is going to be, let's cut this out. Let's withdraw this a little bit. Let's adjust this out slightly, so we can pull that in closer. And because we only want this sort of movement on it, don't we? So we don't want much, do we? And we've put the nut on there now, haven't we? So I think that'll do the trick. Yeah. Okay. Let's do that. So we've readjusted this. Haven't quite tightened it up yet, but that will do. This will do. This will move in and out. Shall we put a nut here? Just on the end? You just don't want them to foul, do you? We're not doing it precise. All you need is something to cock over and it's jammed in there and it won't move, and you haven't got enough power at the other end to release it. And yeah, it's okay, put a load of grease on it. But yeah, we could put a little nut there, couldn't we? Put a little nut there, redo this again. It's looking not bad. Actually, when you look down at it like this, they're sort of in line now, aren't they? So we can make our, cut this plate out here, strengthen that corner, put a nut or a, I think, get a box spanner, cut a box spanner in half, let these run in and out a box spanner. I think that's inside a tube, you know. I think that's probably the answer. Yeah, so we're getting to our goal. Shut is shut and open is shut. It will only open when it's in the middle. I'm quite pleased with that. I think I'm going to call that another part, actually, because you've had loads of different little different films, haven't you? So that you don't fall asleep completely. So that's what we're going to do. Make that fit on the end here and put some sort of a sleeve of some sort here. So that'll go in and out. And it should be a case of just elongating a hole, making a shaft meet these somewhere, and put this side on, which was sort of already half made.